Hello everyone, this is day 14 of 69 days of code. My name is Rajat Upadhyay and today we're going to be looking into yet another interesting topic in software engineering, which is called SQL injection. So what is SQL injection and how SQL injection happens? Why do we need to avoid SQL injection? What happens if we don't avoid SQL injections? All these topics. So let's start off with a very basic question, which is what is SQL injection? So what is SQL injection? Let's break it down into two different parts. Okay, SQL means databases, right? Injection means injecting some sort of code inside your database, right? So SQL injection basically means a sort of security threat to your systems, to your database systems, in which the hacker can run some commands which are unintended from your side. You don't mean to run those commands, right? But the hacker can run those commands on your database, and they can retrieve the complete data or delete the whole database or drop any particular table or just perform some kind of operations that you did not intend to do. So that is SQL injection. And SQL injection happens in a number of different ways. The most common way, if you can see in a web application, is by entering some data into fields, into the input fields. And if the application server on the backend is not properly structured, if it is not properly written, the code is not properly written for database queries, then that particular malicious code can cause your database tables to be dropped or your data to be deleted or updated or anything else. So I'm going to share my screen now. So here in this D14, I have all the SQL injection notes that I've created, and all these images which contain all the different types of notes that have been created. And on these three, more you can say probably the best sum up of all the topics that I did while studying this SQL injection. And as how does SQL injection happen? So let's say that you are creating a query to a particular database in your backend in which you are storing the user data. And the user data in the front end, it has two forms, a username form and a password form. And the user enters the username and the password in the front end form. And this data is being passed into the backend. And this both these details, the username and the password, which is passed into the backend, this is being entered inside a query dynamically, right? So let's say the query is this: insert into users table values your username and your password, both the variables which are inside your username and password. And this query is being run inside your application. Maybe it's a Node.js application or a Python application, whichever application it is, this particular query is being run. Assuming that the user enters the username, some particular username, right? Let's say this is my username, I enter this, and my password. Okay, if we enter this username and the password, it will work properly as it is expected, and it will enter a new record as Rajat W199 and password 123 inside the database. But in case if the user enters something like this, if this is being entered by the user, which is a malicious code, sort of a malicious input which is being entered by the user, and this particular variable will directly be input over here. What will happen in that case is, let's say I put a single quotation mark over here, and I have my query like this in the backend. In that case, this particular thing will be copied from here and put into the backend inside the username. Now, according to SQL, this particular query ended over here because of this single quotation marks. And after this semicolon, there comes the next query, right? Or something like this. So what does the next query do? The next query will say drop users. So as soon as this particular query is done, drop users query will be called, and in that case, your users table will be dropped, right? And this is just one example of SQL injection in which not validating the user input properly caused our users table inside our database to be dropped. So the hacker somehow figured out what is the table name, or maybe through hidden trial, they figured out that maybe the table name is users, and they entered this particular statement and the table was dropped. This is just one example. Another example can be selecting all the data from the database. So in case of a select statement, we can say select star from users, let's say bank statements, where ID is equals to something. So if a particular user is entering a particular ID, that particular ID we want to select his bank statements. But what if instead of entering his ID over here, the user makes a query in which instead of saying the ID, he just instead of saying ID equal to 23, he said 23 or 1 equal to 1. Okay, so instead of entering the ID value is 23, here he entered this value. This is the value for his ID. In that case, dynamically, the variable ID will be entered here. And if you look at this query, what this query will do is, if ID equal to 23 or 1 equal to 1, this 1 equal to 1 will always be true, and there is an OR condition over here. That means this whole thing will be true for all the records. That means all the records from the bank statements table will be returned, right? Which means not only that particular user's bank statement, but all the bank statements which are present for all the users in the database, they will be returned to that particular user. And all of this just because he entered, instead of 23, just another input over here, which will return back some data to that particular user. So this is another classic example of SQL injections. Now, the example can go on and on, but the most important question is, how do we prevent SQL injections? There are a number of ways, but not any one single way is going to ensure that we are completely secure against SQL injection attacks. The reason for that is, with time, cybersecurity threats become more and more clever, and one cybersecurity threat for which we have put up a particular patch or a security patch we have put out in our code, it is possible that with time a new more clever threat might evolve, and our code might not be able to handle that. So in that case, we can say that no one particular solution is going to be enough for this. Maybe applying multiple solutions is going to provide us a particular probability, but not always 100%, right? So let's look at all these different ways of preventing SQL injection attacks. So one very simple common way is, instead of directly entering over here, let's say I'm creating a route in Node.js and I'm saying to post something. And here I'm creating a query, let query, and I'm saying const is equals const username is equals to rec.body .username, and let query is equals to select star from users where username is equals to, and here we are what we are doing is we are directly concatenating the username like this, right? So what is this? This is kind of a string concatenation. We are concatenating one string with another string. In this case, there is no any sort of check happening that is checking whether this particular username is actually a username or a SQL injection code, right? So this is one very classic example in which SQL injection can happen very easily. So something known as parameterized query, or you can say placeholder, in which case we are not going to directly concatenate values like this, but as shows connection, we write the query over here. Wherever they have some dynamic value, put question mark, and then after a comma, the values are passed as another parameter, as an array. So in this particular question mark place, this rec.body.dob will be passed, and this question mark place, this rec.body.account number will be passed, right? In this case, this sort of, if this is a SQL injection code attack, right? If let's say if this particular value is a SQL injection code, so this will not run because SQL will internally handle this, and it will not consider it as a normal string or a SQL command, but it will consider it as a placeholder or a value, and it will not run the SQL injection code in case it is a SQL injection code. So this is one of the best ways to avoid it. And other ways can be checking. One of the other ways can be checking for particular SQL injection codes, which are very famous on the internet. So if you are aware, if you can find some on some websites, some particular SQL injection code attacks, and before running your query on the database, just validate your user input through all those common SQL injection attacks and check if any of the SQL injection attack matches, right? But again, in that case, you will have to keep updating the SQL injection code attack array, right? You will have to keep updating it, and at any time a person who is really clever in hacking, he or she can come over there and hack it anyways. So that is not a 100% safe solution, but it is just one solution that can be applied easily. And this is another solution that can be applied easily. The third solution is actually purchasing a particular software, which is called a firewall. So web application firewall. What web application firewalls do is they help protect web applications by filtering and monitoring HTTP traffic between the web application and the internet. So it's pretty obvious what they are doing. They are monitoring complete all the HTTP requests, right? And they are monitoring all the request bodies and everything. And they are checking whether any particular query has a threat of inducing sort of a bug or a hack inside your application, and it will let you know. But again, this is not a free solution. You will have to purchase these softwares. So on a personal level, while creating personal projects, this is not useful. But while creating production projects, companies can purchase this and put a firewall in front of their servers to make sure that those attacks are not happening in the production environment. So this is another useful way of avoiding SQL injection attacks. You will find all these notes over here. Parameterized queries, just we look into these placeholders parameterized query, in which we don't directly concatenate it as a string, but we pass the values inside the arguments. One of the best example is avoid administrator privileges. So one of the worst things that can happen in the production environment is all the database will be deleted, right? That table will be dropped in case of SQL injection attack. So for that, the credentials that you are passing in your production environment to the database credentials, the username and the password, that particular username and password should never be provided the complete administrative privileges, right? The complete administrative privileges, as in they should not have the complete hold of the database, as in performing all the operations, deleting and fetching all the data, right? So maybe the username and password that is created for a database in the production environment, it should not have the deletion feature. So it should not be able to delete. It should not have that you can say permission, right? And again, one of the other things which can be done is we can avoid fetching a lot of data at one time, right? So we can put a limit. Let's say that if more than 1,000 records are being fetched at one time, then block that request, right? And inform the administrator that more than 1,000 requests were being fetched. Because in case of a normal web application, right, it is not possible that a person is fetching more than 1,000 requests at one time. If they are not creating reports, obviously, if they're creating reports, then in case of reports, all the data is being fetched, even if it is a million records. But in case of normal OLTP transactions, we don't really fetch a lot of data. Even if we are scrolling through Instagram or we are fetching some data of our school records, it is paginated always, right? Maybe 50 records at one time, not 10,000 records at one time. So if it's 10,000 records at one time, in such application, it might be possible that SQL injection attack is happening, right? So these sort of things can be done. Again, the web application firewall you can see at the bottom of this image. This is one of the ways to avoid it, right? And it also, web application firewall not only avoids SQL injection attacks, it avoids a number of attacks, right? Session hijacking or cross-site scripting or DDoS attacks. So yes, that money that is put into it's totally worth it. So these are the different ways of avoiding SQL injection attacks and what SQL injection attack is. And obviously, if we don't avoid SQL injection attacks, it can cause a number of issues. For our personal projects, it's not a big issue, but in case of production applications, we can lose our passwords to SQL injection attacks. We can lose even credit card information if a company like Paytm is being hit, right, by hackers, and they can lose credit card numbers and everything, all the personal sensitive data of the users, which is not good at all. So to avoid SQL injection attacks, there are a number of ways, and that is about it. Thanks.